Hello and welcome along to another lesson with Mr. Burns. This video will concentrate on the introduction of solving equations. Now, a typical question would be to ask you to solve the following equation. It might even just say solve. And what we have here, the equation we have here, is 2x plus 1 equals 5. So what this is saying is that the left-hand side is 2x plus 1, and the equals is saying that the right hand side is 5. The left hand side is always equal to the right hand side. So 2x plus 1 is equal to 5, and 5 is also equal to 2x plus 1. Okay, if we were asked to solve an equation, this means to rearrange the equation to find the value of x, right? And you are required to do this algebraically, showing steps. Okay, initially, when you're looking at this further down the school, you would be looking at it and solving it through inspection, just by looking at it and saying the value of x must be 2, because 2 times 2 plus 1 is equal to 5. You are absolutely spot on with that, but you would have to do this and show this algebraically. So, we are going to learn to apply inverse operations to solve equations for an unknown variable. Okay, so for example, solve 2x plus 1 is equal to 5, where x is a member of the real numbers. Okay, so what we're saying that there is that x has to be a number which exists on the real number line from negative infinity to positive infinity. The reason we are sharing that with you just now is because that is not always the case. Right? In the junior school, this will always be the case. Later on, you will meet symbols like this, and it's important that you get this information to you as early as possible. Okay, so let's look at that again. We are learning to apply inverse operations. Okay, we'll talk about that in a wee minute. To solve equations, so you by now should know the difference between an expression and an equation. Okay, if you do not know the difference between an expression and an equation, then please visit the earlier videos in the playlist of algebra and familiarise yourself with this. The unknown variable in this case is x. Okay, we don't know what x is at the minute. Yes, we can solve it through inspection, but when they get more complicated, you won't be able to do that. Okay, and how we go about solving equations will always be to apply inverse operations. Okay, so in general, right, these equations that we're going to look at initially, this introduction, will all be linear equations. Okay, they all take the form, in general, ax plus b equals c. Okay, for these ones that I'm going to discuss with you, right, where a, b and c are also real numbers. Okay, so they can be any value. Right, so in the previous one, if I have a wee look back at it, A was equal to 2, B was equal to 1, and C was equal to 5. Okay, that is not always going to be the case, right, but they do all exist on the real number line. Okay, now to solve equations, right, this is going to be what you're going to get used to hearing all the time at the high school. To solve equations, we will change the subject to the chosen variable you are solving for. Okay, in this case, the chosen variable is x. You will solve it for x. The procedure that you're going to follow is called changing the subject. When you have the variable on its own, then this is your subject. Okay, by convention, the subject is normally on the left-hand side of the equals, but it can also be on the right-hand side. Typically, we keep it on the left-hand side. Okay, so let's talk that through again. When you have the variable on its own, at the minute here, It has been multiplied by a value, right? Any value on the real number line. So it can be 2, it can be 3, 5, 7, 200, 3.6, anything at all. When you have the variable on its own, then this is called the subject. You have changed the subject. The subject is now x equals. Right? The left hand side is x, the right hand side is 5. X is equal to 5. So here we're saying x is on the left hand side, spot on. X is a subject, that's what we want. X is a variable, right? It varies. It's important to know that x can take any value, right, on the real number line. This is why we're saying this here. X can take any value on the real number line. It isn't always equal to 5. Okay, this is just an example. Okay, so what you'll have seen probably so far, maybe lower down in the school, which are all linear equations. X is equal to 1. Okay, that's actually a solution. Right, that's now the subject. Another example, x plus 1 equals 2. Another example, 2x plus 3 equals 5. Another example, 5x plus 4 equals 3x plus 6. Okay. Now it's important to be familiar with the generalisation of that as well. Okay, so x can equal any number, a being a member of the real number line. Okay, so it doesn't always have to be 1, like it is in this example. Okay, we can apply operations to it, we can add values to it to equal, right? Ax plus b equals c, ax plus b equals cx plus d. So just by looking at this slide, you will see what I mean by its general form. Okay, so this is just an introduction. It's letting you see examples of what we call linear equations, which is what you're going to do to solve in the later videos. Now, what we also have to discuss with you before we go ahead and solve it, we did say we were going to apply the inverse operations. Okay, so if you've got an equation that has an addition of it, an addition, then to apply the inverse operation, you will apply subtraction, right? You will minus, right? That's you applying the inverse operation. When you see the examples in the next videos, you will understand fully what this means. Now, applying the inverse operation of addition is actually called the additive inverse, right? You know that as subtraction, right? You know that as minus. Minus is the operation. If you were to subtract something, that is the doing part, that's the verb. Okay, so in the previous one, you've got x add a value. Okay, if that operation there wasn't plus, and you would probably look at it and say, well, it's subtract, the operation is actually minus. Okay, so that would be x minus a is equal to b. Okay. Similarly, this operation is minus, the inverse operation of minus is addition. Okay. Multiplication, right, that is repeated addition. Its inverse operation is the multiplicative inverse, which you know as division. Okay, so by applying these inverse operations, we are building your skills for later on in your maths. Okay, and that will be the language that we'll use throughout the videos to follow this. So operation division, inverse operation multiplication. Okay, to solve equations, we will apply the inverse operations. Okay. Okay, thanks for watching.